Our paper, Biology's Dark Matter from Galaxies to Microbes, has just been published in Theory, Culture and Society. And in this paper, we trace the emergence of the term biological dark matter in the scientific media. And we examine what's at stake when a concept like dark matter is translated from the physical to the life sciences. I'm Adam Searle, and I'm a cultural and historical geographer at the University of Nottingham, which is in England. And Simon Vanderstraeten was the other author on this paper, and he's a philosopher of science at the University of Liège in Belgium. And it's been really interesting collaborating with each other on this. We have a long history of collaborating together. We worked together on a European Research Council funded project that examined the use of genomics in the bovine industry, and we critically examined how human values are translated into non-human bodies using emergent practices in science and technology. But Simon and I have had the shared research interest in questions about how biologists map the world from the molecular scale up using these technologies. And for us, metagenomics and metagenomic sampling offered a very interesting new paradigm within which to ask these sorts of questions. And with the emergence of metagenomics came terms like biological dark matter, which would be used to describe vast quantities of microbial life that had previously exceeded scientific or taxonomic classification or appellation. So I'll pass on to Simon now, who'll talk about the paper itself.
In this paper, we start with a brief history of the dark matter concept, as it emerged at the crossroad of three disciplines, mainly astrophysics, particle physics, and cosmology. The notion has a long and passionate history concerned with various cosmic entities considered invisible and yet influential. All along this first point, we emphasized all the steps and transformations underwent by the concept to reach its contemporaneous status. Inspired by Belgian philosophers Didier Debèz's take on Whitehead, we were guided through this history by the notion of irreversibility, meaning how a concept gains such traction in a given field so as to transform it and hinder every step back to the world as it was before. Despite the lack of direct dark matter observation, it would be too costly to get rid of the notion, as one would now have to reconsider all the Newtonian gravitational equation. In a nutshell, dark matter characteristic would therefore be summarized as being a massive and invisible particle interacting only through gravitation forces and yet constituting roughly 25% of the observable universe. Now, this narrative is precisely what drew microbiologists' attention on several occasions and is now recycled by researchers working with metagenomics, who are revealing in various environments a large number of genes considered unknown. The narrative pattern emerges again as these unknown entities represent the majority of the living creatures living in those environments while remaining undetermined. Our paper tackles this narrative and its effect within biology. We argue that dark matter draws its influence and strength from the symbolic and problematic history of knowledge pictured as light advancing upon uncivilized, unknown darkness. While we critically engage with the notion, we wanted to remain accurate towards microbiologist passion revealed by the concept's use. Indeed, the dark matter adjective is attributed to microbes mainly because of the phenomenon of horizontal gene transfer, or HGT, that delivers a metamorphic version of the microbial world. So, if biological dark matter doesn't produce the same irreversibility in biology than what it did for the physics science, we argue in our article that it underlines interactivity as a contemporary challenge to the science interested in the living beings. HGT forces biology to craft new words and concepts to make sense of this blurriness. It requires researchers to reconsider structuring notions such as the species, the individual, or the gene itself. We argue that biology's dark matter indicates important changes in biology that we, as geographers, philosophers, and STS scholars, should follow and think with.